Here's the question that I asked at the end of the last piece of the lecture. The idea here is that when we rub the wool and the plastic rod together, they're both charged, but they're charged with different types of charge. So, first we touch the wool to the metal ball, and that gives it one kind of charge. It's what I've been calling glass charge. And then when we touch it with the plastic rod, we're adding plastic charge to it. But we've seen that these charge types cancel out. A normal neutral object has equal quantities of both. So what we should expect is that after we touch the metal ball with the plastic rod, it should be less charged than it was. In other words, it should exert weaker forces on the lint and dust. What we've just seen is that when we add plastic charge to glass charge, we seem to cancel them out. We would end up with less total charge. This is a lot like what happens with adding positive and negative numbers. A large positive and a large negative number can add to give a small magnitude number. Now, I want to stress that this is a choice of model. There's nothing about charge that dictates that it is positive or negative. And furthermore, there's nothing that tells us which of plastic and glass should be positive or negative. It's a choice, an arbitrary choice. But that choice was made quite a long time ago by Benjamin Franklin, and in the terms we've been using, what we know as plastic charge is negative, and what we know as glass charge is positive. We're now ready to state our charge model. And it's first of all that charge comes in two types, and we're going to call them positive and negative. And charged objects exert electrical forces. Like charges repel and opposite ones attract. And both positive and negative attract neutral or uncharged objects. And it's also important that this electrical force decreases with distance. Charge itself is transferable from object to object. When you touch a charged object to an uncharged object, some of its charge tends to transfer over to the other object. The demonstrations I've done haven't really shown that charge is conserved. You have to do some somewhat more sophisticated experiments to show that, but it is conserved. We can move charge around, but we can't create it or destroy it. Another important point is that neutral objects contain equal quantities of positive and negative. If the charge is conserved, the only way you can charge objects is if they already contain a bunch of positive and negative, and they're neutral because they've got equal amounts. Now, to give something a negative charge, you can either put negative charge onto it or take positive charge off. To give it a positive charge, you can put positive charge on or take negative charge off. Now, as it turns out, much of the time it's going to be the negative charge that moves around, not the positive. But we can still charge objects either way by adding or removing the negative.